Hey learners, welcome back to my channel Maths Made Easy with AB. So today is the third lecture on play with graphs. Today we will be looking into some important graphs. In the earlier videos we have seen straight lines, we have seen how to draw parabolas, we have learned about maxima, minima, a basic of that. Today in this lecture we will be covering about circles. We will be looking how we can draw circle. We will be looking into drawing hyperbolas and also ellipse. So let me tell you, so these are all parts of conic section. These are all part of conic section which you will study in the coordinate geometry class. I will be releasing videos on coordinate geometry soon. So you can see further the description, more description part in terms of x, y, what all equations can come into the picture. So the lecture that I am doing today is the elementary part, how you can draw circle, how you can draw ellipse, how you can draw hyperbola, the basic equations that evolves around these. For further videos, we will be seeing the conic section and there I will go into details. Yeah. So let's get started with circles first. So general equation of a circle, so the general equation of a circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So a circle, the equation of a circle is represented by x square plus y square plus 2gx plus 2fy plus c is equal to 0. Remember, the circle this has its center at minus g comma minus f, has its center at minus g comma minus f, and it has a radius, of root over g square plus f square minus c. I think this must be very clear to you all. Yeah. So this is the equation of the circle, general equation of a circle, the center and the radius. Okay. So I think you must have noted this down. Since you have done this, let me erase this part. Let's take an example of how do you evaluate this. Yeah. So I'm not erasing the general equation. I'm taking an example of a circle. So x square plus y square minus 2x minus 4y minus 4 is equal to 0. Say for example, somebody has given you an equation x square plus y square minus 2x minus 4y minus 4 is equal to 0, and first they have asked you to plot this. Okay, so I will plot it on x-axis and y-axis, but before that let us find the center of the circle. So if I compare this equation with this, what is the value of g that I get? So basically over here 2g is equal to minus 2, 2g is equal to minus 2. So the value of g that you get is equal to minus 1. Clear? The value of g that you get is equal to minus 1. Similarly, this 2f is equal to minus 4. Similarly, this 2f is equal to how much? Minus 4. So the value of f is equal to minus 2. Clear to you? Very simple. So I'm just comparing this with this. You have to be very clear with this. So what will be the center of this circle? The center of this circle, I'm writing it here, is denoted by minus g comma minus f. It is minus g comma minus f. So the center of the circle will be 1 comma 2. So the center of the circle will lie at, the coordinate of the point will be 1 comma 2. Very simple. What will be the radius of the circle? So the radius of a circle, already said by the formula, is denoted by the formula g square plus f square minus c. G square plus f square minus c. What is g square? G square is 1 square, 1. What is f square? F square is 2 square, that is 4. And minus c, the value of c is how much? The value of c is how much? The value of c is minus 4. So this will be minus of minus 4, this will be 4. So 1, so basically this is 1, this is 2 square, that is 4, and this is minus of minus, so this is plus 4. So 4 plus 4 plus 1, root 9. So the radius will be 3. So the radius of the circle will be 3. So basically now what you have been asked is to draw a circle with center 1 comma 2 and radius equals 3. Let's see how we can draw this. You have been asked to draw a circle. So I'm drawing it. So this is basically the x-axis, this is basically the y-axis. Students, please note, this is a very simple circle question. We will be looking into complex circle problems in coordinate geometry when we start circles over there. So basically in class 12 generally it is covered. Yeah, towards the end of class 11 also many of the students, they generally do it. So let us see this. This is a basic structure, because I am planning to move you all, push you all from here to functions and calculus, integration and all. That's why I am giving you a basics of this. If you are planning to study this in deep, this video is not for you. So basically, if you have started studying about circle, this is not the video for you. This is the video for those who are studying graphs, drawing basic graphs. Eventually, when we move deep into graph also, then we will be seeing complex problem, applying mod here and there, applying various special functions like signum function, greater integer function and all. Yeah, so we will see that in coming videos. So let's get started with a simple one. So 1, 2 is the center of this circle. So 1, somewhere here will be 1 and somewhere here will be 2. So this becomes the center of the circle. The center of the circle is 1, 2. Now, how will it be? This will be the circle. How did I draw this? How did I draw this? So this length was 1, right? This length was 1, this length was 1, this length was 2. This was 1. And you see, this distance should be 3. So basically it will be cutting from here. So this is r, the radius r, the value is 3. So this is the circle that we have drawn. So basically the equation of the circle was x square plus y square minus 2x minus 4y minus 4 is equal to 0. So with a radius of 3, this becomes the graph of the circle. Yeah. So now students, I am also teaching a very important concept over here, since we have drawn this and we were drawing some graphs. So basically, is this a function or not? So basically, if you have been given a graph and you have been asked if this graph indicates a function or not, so how do you determine that? I will be teaching this in function, but I am telling you over here. So if for that, what you have to do is you have to draw a line, a vertical line you have to draw. So basically, if a vertical line cuts a given curve at more than one point, then it won't be a function. If a vertical line at any point of the curve, if you are seeing it cuts the curve at more than one point, then it will not be a function. In functions class, we will know why. We will see one, many, one relation. So we will be studying relations, and there I will explain you in deep. But now, since we are already doing graph, you need to understand which graph is a function and which graph is not. So I'll tell you over here. Do keep this in mind. Okay. Say for example, you have been given this parabola. So this is a sideward opening parabola. Yeah, this is a sideward opening parabola. So this is x-axis, this is y-axis, and you have been asked whether this is a function or not. So what you have done, you have drawn a vertical line. This vertical line cuts the parabola at 2 points. So this is not a function. Very clear to you? This is not a function. Let us take another example. Say for example, you have been given a parabola which is upward opening. We have dealt with upward opening parabolas, how to draw, in the previous lecture. So do refer those videos if you have not seen already. So if you get this upward opening or downward opening parabola, and over here you are drawing a line, draw a vertical line at any place. This will cut the curve at only one point. You won't get a single point where it cuts the curve at 2 points. It is not cutting. It is cutting at 1 point. If you draw a straight line, it is cutting at 1 point here. Here, this line is cutting here. So 1 point. So this is a function. So parabola, you need to remember, parabola, if it is upward or downward opening, those will be functions. If parabolas are sideward opening, those are not functions. So I think this must be very much clear to you all by now. I am drawing a random curve. Say for example, I have drawn this curve. So this is a sine function. We'll get into sine function and all in coming lectures. So this is the graph of sine function. And if I ask you whether this is a sine function, I already told you this is a sine function. So sine function, if you draw a line, a vertical line, It cuts at one point only. The vertical lines cut at one point only. You cannot see a single place where it cuts the graph at 2 points. So this is a function. So this is a function. Is a circle function? No, because circles will always be like this, circular. So wherever you draw a line, it will cut the graph at 2 points. So circles will never be a function. This was the main thing I wanted to teach you over here. Say for example, you have got a curve which is something like this. You have got a curve which is something like this. This is x-axis, this is y-axis. And you have been asked, say for example in MCQ questions they have given you 4 graphs they have drawn. And they have asked you which is not a function. They have drawn graph and asking you which is not a function. This is a very common question that you get. So what you need to do, you need to draw a vertical line and need to check whether it cuts at one point or not. So this is the graph for example. Now you are drawing a vertical line over here. Oh, see, if you draw vertical line over here, it is cutting at one place, at 2 places, at 3 places. Oh, this is cutting at 3 places. So this is not a function. This graph that has been drawn is not a function. So this should be very much clear to you by seeing graph. So this is by seeing graph determining whether the graph is a function or not. So basically you need to draw a vertical line. Please students, note it down somewhere, keep it at a very important place where you can revise later on. So by seeing a graph, this is the method by which you can determine whether a graph is a function, is a graph of a function or not. How it will be useful, we will see this while we deal with function. And we will also understand the concept that we are taking and we will try to prove it in some other lectures. So coming back to circle, we already saw that the equation of a circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0, where the center is minus g comma minus f and the radius is g square plus f square root over g square plus f square minus c. Yeah, right? So let us, for example, somebody has asked you to draw the circle x square plus y square is equal to 4. Very simple. X square plus y square is equal to 4. Over here, if you convert this, so this is basically x square plus y square minus 4 is equal to 0. Where g is equal to 0, f is equal to 0. Compare this equation with this equation. G is 0, f is 0. So the center of the circle is 0, 0, which means origin. So this circle has a center at origin. What will be the radius of the circle? What will be the radius of the circle? So the radius of the circle will be g square plus f square, right, minus c. So minus of minus 4, that is 4. So the radius of the circle is 2. Very simple, very easy. The most general circle that comes is this. This is x-axis, this is y-axis, this is the origin 0, 0, and this circle has a radius 2. This circle has a radius 2. So basically this part will be 2, this part will be 2, this part will be 2. In fact, this part, any part will be 2. The radius of the circle is 2. So how to draw tangent, what will be the equation of the tangent, we will see that in coordinate geometry. Also that can be solved using calculus. That is the application of differentiation. Yeah. So we will be seeing that later on. So now students, circle is fine with this much. Circle we will deal with right now. Let us see how to draw ellipse. Let us see how to draw ellipse. Yeah. So I am writing it down. Let us see how we can draw ellipse. So the equation of an ellipse is x square, let me write it with a different color pen, x square by a square plus y square upon b square is equal to 1. Yeah. Over here, see, I'll tell you, this is basically ellipse. When x is equal to 0, when x is equal to 0. So this part becomes 0. So y square becomes equal to b square. So y is equal to plus minus b. So this curve will cut the y-axis at 2 points, which is plus b and minus b. 0 comma plus b, 0 comma minus b. When y is equal to 0, you will get x is equal to plus minus a. You will get x is equal to plus minus a. This part becomes 0, x becomes equal to plus minus a. Here the graph will cut, the curve will cut the x-axis at a comma 0 and minus a comma 0. So the graph will be somewhat like this. Say for example, A is greater than B. A simple one, yeah. In details we will deal in different chapter. X, Y, this part cuts, this is the origin 0, 0. This part is A, 0. This part is minus A, 0. This part, positive part, is 0, B. This part is 0, minus B, which we got from here. So this is the basics of ellipse. This is how you evaluate ellipse. Is ellipse a function? No, ellipse is not a function because what students I taught you just now, if you draw a vertical line, it cuts the graph at 2 points. So this is not a function. For simplicity basis, or just a trick that you can remember, if you see an equation and you see the power of y to be more than 1. So if the power of y is 2, 3, 4, 5, 6, that won't be a function. If the power of y is 1, it means if you see something equation where power of y is 1, that means it will generally be a equation, that it will generally be a function. Yeah. So we'll see that later on. So from graph, ellipse is not a function, and this is how you draw a ellipse. Let us see the next question. Let us see how do we draw hyperbola. Let us see how do we draw hyperbola. So here we will be seeing how to draw hyperbola. So guys, you must have noted, I don't know, I'm not sure whether you have already gone through coordinate geometry or not, but if you would have gone through coordinate geometry, this class would be a cakewalk for you. But if this is the first time you are looking into graph, so I think this is the stepping stone. You must read this first and then go to conic section and other chapters. So this is a hyperbola. I'll mark with a different pen. So basically hyperbola, the equation of a hyperbola is marked as x square upon a square minus y square upon b square is equal to 1. Just the sign changes. X square upon a square minus y square upon b square is equal to 1. When x is equal to 0. When x is equal to 0. So this part becomes 0, right? When x is equal to 0, this part becomes 0. Y square becomes equal to minus b square. Can y square be equal to minus b square? This is a positive part and this is a negative part. So this is not possible. Imaginary roots will come. It means you will get no values of y, which means what? The curve will not cut the y axis. Curve won't cut y axis. Why? Because when you put x is equal to 0, y square becomes minus b and y gives imaginary roots. So here you can clearly see that it will not intersect, the equation is such that it won't intersect the y axis. Very clear to you? I am erasing this part. Yeah. So y axis the curve won't cut. If say for example I take y is equal to 0. So this part cuts, you get value of x to be plus minus a. The value of a, x square becomes equal to a square, so x becomes equal to plus minus a, right? So it means the hyperbola will cut x axis at 2 points which are plus a and minus a, which are plus a and minus a. This is the origin. The curve is not cutting the y axis, already told you before, and it cuts the x axis at a comma 0 minus a comma 0. This is the point. These are the 2 points where it will cut. I think this is very clear to you all. This is the x axis, this is the y axis. So this is the hyperbola. Is this a function, student? No, because if you draw a vertical line, it will cut the hyperbola at 2 points. So hyperbola is also not a function. Also you see here it is square. I told you just a few minutes back that the power should be 1 to be a function. Yeah. So this is one hyperbola type. Let us look into the other hyper. So if somebody is asking you to find a general point on this hyperbola. Somebody is asking you to find the general point on this hyperbola. So what will be the general point in this hyperbola? By general point, what do I mean? I mean to find the value of y. So I mean to find the value of y. So y square upon b square, will it be equal to x square by a square minus 1? So I am solving this, students. Y square upon b square, taking it that side, x square by a square minus 1. Yeah. So y square will be equal to b square into x square minus a square upon a square. So the value of y will be b by a, this is square, yeah, square root x square minus a square plus minus. The value of y will be plus minus b by a root over x square minus a square. So this is a general value of y that you are getting for different values of x, for different values of x. So this is clarity on hyperbola that you have got. So let us look into the next, equation of hyperbola. So we are still in hyperbola part. So let the next equation be minus x square upon a square plus y square upon b square equals 1. Minus x square upon a square plus y square upon b square is 1. Earlier we had seen x square upon a square, this was minus. So here the case will reverse. Here the case will reverse. Just the graph will be like this. Thus the graph will be like this. This will be the x-axis, this will be the y-axis, and these points will be b over here now, 0 comma b, and this will be, so this is the point, yeah, the curve is moving like this, don't think it to be this way. So this point will be 0 comma minus b. This is also not a function because it cuts the y-axis, the curve at 2 points over here and here. So this is also not a function. I think this is very clear to you all. By now, for more details, just refer to the conic section. Yeah, so this is the graph of this hyperbola. Let us look into another part. So we have done hyperbola now. Since we have already done hyperbola, I'll just touch rectangular hyperbola also. So basically the equation of a rectangular hyperbola, say for example xy is equal to k. Somebody has asked you to draw xy is equal to k. So if k is greater than 0, the hyperbola x-axis, this is y-axis. If k is greater than 0, the hyperbola will look like this. If k is greater than 0, the hyperbola will look like this. You can just deduce it. So this is positive, y is positive. That's why it is lying in the first quadrant. K is positive, right? So this must be positive, this must be positive. Hence first axis in the first quadrant. Y in third quadrant? In third quadrant, value of x and y both are negative. So negative into negative, it will give you positive value for k is greater than 0. You got it? Why this logic? If, I'm just noting it here only. If k is greater than 0, say for example, if k is less than 0, which means k is what? K is negative. So if k is negative, which axis it will go to? It will just reverse. This will just reverse. It will become like this. Yeah, you have to get negative. So one should be positive and another should be negative. That's why the second quadrant and the fourth quadrant, the graph will lie. So this is one such equation that you got. Let me show you another equation. So the another equation is, say for example, x square y is equal to k. X square y is equal to k. Now you know the logic. Now you know the logic how we are drawing. So k is greater than 0. If k is greater than 0, what will be the graph? If k is greater than 0, the graph will be like this. So these are asymptotes. So the axis become the asymptote. So we'll study about asymptotes in later parts. So this is x-axis. This is y-axis. Yeah. So this becomes the graph of x square is equal to x square y is equal to k, where k is greater than 0. What happens if k is less than 0? What happens if k is less than 0? What happens if k is less than 0? Similar way, in a similar sense, this graph will turn into this. This graph will turn into this. This is not cutting, this is the asymptote. Yeah. This part will turn into this. So this is the graph. So this is the graph basically when k is greater than 0. So students, let me tell you, so this was the part for circle, ellipse and hyperbola. Also rectangular hyperbola we have covered. So this was the very basics, and you should memorize. This should be in your tip. You should understand that with this graph you can go ahead with functions. So these will form the basics of graph. Using all these graphs, parabola, hyperbola, straight lines, we will be moving further deep into graphs, and then eventually the functions and all calculus will become very simpler for you. Even coordinate geometry will become very simpler for you. So guys, in the next video for graphs, we will be looking into the transformation of graphs. So basically, how do straight lines shift? So fx plus a some number, or fx minus a, f a times fx. So we will be seeing in the next lecture. Guys, if you have any doubt, you can just post it in the comment section and I'll revert to that. If you like the video, do subscribe to our channel. Thank you so much for watching this.